Today, we are going to unpack something really beautiful in geometry. We're going to start with just 2 circles and a handful of lines. And by the end, we're going to uncover this surprising, perfect alignment that seems almost magical. So let's jump right in and see how it all comes together. So this really gets to the heart of what we're looking at today. You know, geometry isn't just about memorizing formulas. It's about these elegant, hidden rules that govern the world around us. And sometimes, these rules lead to results that are so perfect, they almost feel like a wild coincidence. We're about to pull back the curtain on one of those moments.
Okay, let's get started. Section 1, a tale of 2 circles. We're going to build our whole geometric world from the ground up, starting with the absolute basics to lay the foundation for our puzzle.
And here they are. Our story starts with just 2 circles. The smaller one on the left, let's call that omega, with its center at point M. And the bigger one on the right is gamma, with its center at N. And that difference in size, that's actually pretty important right from the start. Now, these circles overlap, and they cross each other at 2 really crucial points. We'll label them A and B. You can think of these as the bridge connecting our 2 circles. Point A, especially, is going to be central to pretty much everything we do from here on out, so keep your eye on that one. All right, our foundation is set. Time for section 2, drawing the map. Now that we have our main shapes, we need to start adding some lines and points that are going to define the landscape of this whole problem. So, the first logical thing to do, well, let's connect the centers of our 2 circles. This line, running from M to N, it's going to form the central axis of our entire diagram. It's like the spine that everything else is going to be built around. And as this line passes through the circles, it naturally hits their edges. Where it crosses the smaller circle, omega, that's point C. And where it passes through the bigger circle, gamma, we'll call that point D. So just notice the order here. We have C, M, N, and D, all lined up from left to right. Now here's where it gets interesting. We're going to connect point A, remember our key intersection point, down to both C and D. And just like that, we've created a brand new shape, triangle ACD. This triangle is really the key that's going to help us find our first special point. Which brings us to section 3, the special centers. To really unlock this whole puzzle, we need to bring in 2 very important concepts from geometry. You can think of them as our star players, each with its own unique properties. First up is the circumcenter. Now, what is that? Well, put simply, it's the one single point that's the exact same distance from all 3 corners of a triangle. And because of that, it's the center of a circle that passes perfectly through all 3 of those corners. Every triangle has one. So let's go ahead and find the circumcenter for our triangle ACD. We'll label this special point P, and there it is, sitting right there, perfectly equidistant from A, C, and D. Definitely keep your eye on P. It's one of our main characters now. Okay, our second star player is the orthocenter. This one's a little different. Imagine you're standing at one corner of a triangle, and you drop a line straight down to the opposite side so it hits at a perfect 90-degree angle. That line is called an altitude. Well, the orthocenter is simply the point where all 3 of those altitudes cross. So now we're going to find the orthocenter of a brand new triangle. This one is formed by our circumcenter P and our 2 original circle centers M and N. So we look at triangle PMN, we draw its 3 altitudes, and where they meet, that gives us our second special point H. All right, our special points, our star players, are now on the board. Let's move on and see how this all starts to build. Section 4, connecting the dots. We're about to draw a new line now that's going to tie several of our key points together in a really neat way. Okay, so we're going to draw a straight line that starts at our intersection point A and passes directly through our circumcenter P. This line just keeps on going, carving a path right through both of our original circles. Where it crosses circle omega for a second time, we get point E, and where it crosses circle gamma again, we get point F. I know, that's a lot of points and letters, so let's just pause for a second and do a quick recap. We've got our 2 circles, omega and gamma, our intersection points, A and B, the points on the center line, C and D, the new points on our path, E and F, and, of course, our 2 special centers, P, the circumcenter, and H, the orthocenter. With all our pieces on the board, we are ready for the final reveal. And that brings us to our final section, the surprising tangent. This is it. This is the moment where all these pieces we have so carefully put into place are about to click together and reveal something elegant and totally unexpected. So after all this work, right, drawing circles, lines, finding these special centers, what was the point? What is the hidden connection that makes this whole thing so special? Well, let's find out. We need just 2 more things. First, we're going to look at 3 of our points. B, which was the other intersection of our original circles, E, the path point on circle omega, and F, the path point on circle gamma. We're going to draw the one unique circle that passes perfectly through all 3 of those points. And now for the final piece of the puzzle. Remember our orthocenter, H, and that line we drew through A and P? We're going to draw one last line. This new line goes through H, and, this is key, it runs perfectly parallel to that line AP. And here it is. This is the amazing result. That very last line we drew, the one that goes through H, is perfectly tangent to the circle passing through B, E, and F. It just kisses the edge at a single point. No overlap, no gap, a perfect tangent. Every single point and line we constructed led directly to this one incredible, perfect alignment. It's moments like these that just show you the pure beauty of mathematics, right? This hidden order, this secret symphony of rules connecting what started as just a couple of simple shapes. It really makes you wonder, doesn't it? What other perfect hidden rules govern the geometric world all around us, just waiting to be discovered?